In a previous video, I showed you how to use Solver as an Excel add-in to do logistic regression. However, when we get to big data, one of the things that we often look at is we have a lot of predictor variables, and we need to determine which of these variables make sense to keep and which one should we throw away. So in this case, what I have is I have a data set that is trying to predict whether or not an incoming email is spam. So a person collected this data, and it's about 20 years old, but it proves the point pretty well here. They went through and they captured whether or not in an email, say the word table was in an email. Okay, and if the email had the word table, then it would have a 1 if it was in there, and it would have a 0 if the word table never showed up. At the very end, they also determined whether or not the email was spam. Okay, so again, data where I'm trying to predict where something is spam on an email based on the words that are in the text of the email and also the average number of capitalized words that were on the email. So I'm going to use logistic regression. Again, it's either spam or it's not spam. So I'm going to do classify logistic regression. In here, you can click on the data range. So again, I clicked on the three little dots, go through, select all of the data. I believe in this case it's A1 through AR 4602. Let's make sure that AR is the last column, that's correct. Okay, let's go ahead and look at, I think whenever yours pops up, it looks like, it should look like, oop, that's wrong. Output variable 1 over there. The output I'm looking at, again, is spam, whether it's spam or not. And then I'm going to take and highlight all of these other variables because I don't know which one makes sense to keep yet. I'm going to put them in as my selected variable. It's going to take a second for them all to populate. There they are. Number of classes, once again, it's either spam or it's not spam. We're going to go to the next. We're going to use covariance, variance, or the variance covariance matrix, and I need analysis of coefficients. I need the summary report, and I'm going to click finish. All right, we have 43 variables in here. Okay, that's a lot. But let's go down here and look. This model says that we can explain almost 71% of all of the variance in whether or not an email is spam or not based on the 43 variables. One of the variables is our output variable. Whether or not those items are, those words are in the email. All right, now let's pull down here a little bit further and look at the coefficients that are associated with each one of these words. Two ways to look at it. From a statistics standpoint, we normally use a 0.05 as the cutoff for whether or not something is statistically significant. And the reason for that is that that's 0.05 means that there is only a 5% chance that this is significant due to random outcomes. All right. So any of our variables here that have a coefficient that are above 0.05, they probably don't make sense to keep them in there. Now, once again, go back and take a look at scientific notation if it's been a while since you looked at it. The way that Excel reports this, 8.88 times 10 to the minus 43, this is really 0.0000. There are 43 zeros here, that come before this number. So if you see this negative value, this is definitely less than 0.05. That's less than 0.05. However, the word address doesn't seem to be significant in this model. And what I'm trying to do is I'm trying to take my model and I'm trying to remove these predictors that aren't adding any extra value to me. Okay, once again, I started off with 0.71 r squared as my starting point. It looks like I could probably remove the word address because it's above 0.05. I could remove the word over, order, mail, receive. So you can see everything that's above 0.05, you could go in and remove those from your model. All right, last thing I want you to do before you think about removing them. Go to your training score, look at your confusion matrix. Right now, this model with all of these variables, those that are not spam, I get correct 2654 out of 2788 times, okay? I get it wrong 134, so I only mess up if it's not a spam. I'm only going to be filtering out almost 5% of my emails because I don't think they're spam, but they really are spam, okay? Again, from a prediction standpoint, this says I don't think it's spam, so I'm going to let it go through. 5% of the time, a spam email is going to get through. Similarly, this one says this is spam, and so in the spam, if I'm filtering things out using this current model, 1,620 times, all right, I get it correct. However, 193 times, I say that it is spam. I filter it out, and it wasn't spam. So in this model, it says there's almost 11% of the time I'm filtering out something that really is not a spam email. So write those down. The model has two outputs. One of them is how frequently do I get it wrong, and what's the total variance that I'm explaining. Logistic regression is really trying to train based off of the r squared value, okay? You cannot increase your r squared, the amount of variance that you explain from a model, by removing variables. Let me say that again. Removing variables is always going to cause your r squared to go down because you have less information in there for it to be able to predict the outcome. However, it is possible when you remove a variable that your error rates could actually get better, all right? Because the error rate is not what logistic regression is training off of. This is just an artifact that gets put out at the end. Let's go back over and look at this again. We said that you could easily make the argument that address could be removed, over could be removed. I'm going to take this off and this out. Let's go back to our data. Let's do another logistic regression. I think we said address could be removed. And we'll just run it with address removed out of there, okay? You should go ahead and remove all of the words that don't, that aren't at the 0.05 level. Okay, I'm going to remove word address. We're using variance covariance, analysis of coefficients. We want summary report. We're going to finish it. Let's see what happened whenever we reran the model. R squared, very similar to what it was before. And it looks like we actually have a little bit better prediction rate here. Your job, once again, when you are looking at a logistic regression, look at your coefficients, see which ones can be pruned, take them out, and see what happens to both your r squared and also to your confusion matrix so that you can prune down your variables to get it down to the ones that are just significant and that makes sense for you to be able to use in your model in the future. All right, good luck.